When you break it from there, you will see this is now what is the Carnot cycle. Carnot cycle has got two isotherms and two what we call as adiabatics at the moment. Two adiabatics, there is no heat transfer, so Q is equal to 0. Two isotherms, there is no change in internal energy. So it makes the cycle quite simple. For a Carnot cycle, we define if it is working as a heat engine, we define the efficiency and we calculate the efficiency. And if it is work this is that just we define the efficiency of the Carnot engine as minus of W by Q the heat we supplied. Okay, now similarly what we do is if we are talking about the COP as a heat form, we define this one that one as a Q minus of Q divided by W. Minus of the Q negative in the system. Thus, we have to calculate engine. If it is working with two sources, this is we call it as this is the source and this is the engine. This is called the W. So this is the amount of Q1 coming from here, this is the amount of Q2 going from here, and this is the temperature T2, and we call it as a sink. So this W will be obviously minus, so that's why we have minus sign there. So minus of the W minus with this minus sign actually makes it plus. So consequently we have efficiency and we found out that this efficiency is nothing but T1 minus T2 divided by T1. It can also be written as 1 minus T2 by T1. Okay. Similarly, the going to the COP, if it is working as a heat pump, when it is same it's reversed. So this is the system, then what Q work here, this is W. So if you say that as Q1, this is Q2, and this is temperature. Here this becomes the source, and where heat is rejected, that becomes the sink. It's not necessarily the source has got to get the higher temperature. Where the heat is rejected, they call it as a sink. Like a garbage. That you may not by mistake, you may but still it is useful, but you throw it there, but it becomes a sink. So, where heat is taken, we call it as a source, where the heat is rejected, we call it as a sink. In a heat pump, we have the work because they are transferring heat from the lower temperature to higher temperature. So, according to Prof's statement of thermodynamics, we want to limit our supply. So, here, this is and the system will be limited because it's going out. So we define COP of the heat pump as negative of Q. That is negative water because so by and large the definition is what we have spent, and this decapulate is what are they telling. So then what happens in case of we want to look at as COP as a refrigerator. If my interest is how much of heat I am injecting here, then this is not. Take a refrigerator or your air conditioner. I want to know how much I think it will come from your refrigerator. So then actually my area, my interest will be now this, there is no heat inside, it is simply Q2 by Q. Okay? Right. From the laws of thermodynamics, what we have is that sigma Q1, then there is sigma Q2 plus W is equal to 0. That is the first law of thermodynamics. First of thermodynamics only it says energy conservation, so Q1 plus Q2 should be equal to 0. So now what happens if it is the COP of the Q1 will be or I have Q1 plus Q2 equal to this is W. So what will happen? My efficiency is nothing but minus of Q1. So this can be written as minus of W divided by minus of W is nothing but minus of W is nothing but Q1 plus Q2 divided by Q1. Okay? Now here we have this becomes 1 plus Q2 by Q1. But this you must know that in the case of this one, if this is Q2, so Q2 we have a negative sign. Okay, that's what this will not apply, Q2 this will be negative. Or even if you take the Q1 minus Q2 divided by Q1, so heat supplied minus heat rejected divided by heat Q1 will give you efficiency P. Okay? So there are two this Q2 will be negative. This note that one, though it is a plus, it doesn't mean that the efficiency will be going to be higher than 1. They are not adding anything, this Q2 will has got to be negative. Why Q2 has got to be negative? Because this is going away from this. And why it has got to go, can I do it without this one? You can't do it. That is what Kelvin Planck's statement said. You cannot build a heat engine with only one heat source. So the Q2 some heat has got to be through. Okay, now I agree. I have to throw out some heat. How much of heat I have got to throw? This is what we have to find out next. So we'll see that in a moment. So now let me go back. So the efficiency is simply 1 minus Q2 by Q1. You will get there. Now let's go to the next slide. So the observations are the work of this, the work of compression during the adiabatic process 3, 4, and 1, 2, they compensate this already. I have mentioned already. I think I wrote repeat this one. From the first half already, this we may have written there. Q1 plus Q2 should be minus of W. So 1 plus Q2 by Q1 is minus of W. So we have this as an efficiency. Efficiency cannot be negative. So obviously, 1 plus Q2 by Q1 again, repeating Q2 will be efficiency of frequency. That's what we take into this. We go to the next slide. 1 plus Q2 by Q1 is equal to negative of W by Q1. 1 plus Q2 by Q1 is equal to that. Q1 by Q2. Come on, do it, guys, girls. First take the equation this way. And then take the load to weight change. Guys, you have to know, slide 50 is taking such a long time for you guys to note down. The notes will ask you, questions are there, class will ask thermodynamics explanation there. Kanapadu pode front lo kuchoka. I shall do the screen over here. Kanapadu konda niku em rastunnam. Is that the 1 plus Q1 by Q2, though we said if it is a completely reversible of efficient engine, it will be equal to, if it is not, it will be less than or equal to minus 2. So, from 2.6 axis is quite simple. You subtract 1 from both of them. So, what do we get? Q2 by Q1 should be less than or equal to minus 2 by Q1. Come on, guys and girls. Yes. What's that? So, if you want to ask now, if you need to do this super Q1 by this way. Q2 by T2 should be less than or equal to Q1 by T1. Which is there? Minus. Which is there? Q2 by Q1 less than Q1 by T1. Which is there? రాసుకోమని అంటే రాసినాం కదా అక్కడ ఇది అర్థమైంది ఎట్లా వచ్చిందని ఈ ఒకటి తీసేసాం అక్కడ నుంచి దీనే దిగుతాం రాసుకో
అక్కడి నుంచి ఇక్కడ చూసి ఈ ఒకటి తీసేస్తే Q2/Q1 లెస్ దాన్ అనేటువంటి T2/T1 కదా రాష్ట్రం T2/T1. ఇప్పుడు ఈ Q Q2/T2 ప్లస్ Q1/T1 షుడ్ బి లెస్ దాన్ కరెక్ట్. అర్థం కాలేదా? ఇది ఈ పక్క తీసి క్రియేట్ చేయాలి. ఓకే, నౌ ఏమైంది ఓకే హీట్ సింక్ హీట్ సోర్స్ Q1 and Q2. So what we have is sigma of Q/T is equal to less than and equal to 0. Okay, ఎప్పుడు 0 అవుతుంది? sigma of Q/T is equal to 0 when it is completely reversible. It will be less than 0 when it is not reversible. So this way we distinguish between reversible and irreversible. నేను ఆ రోజు ఎగ్జాంపుల్ చెప్పాను, వాట్ ఆర్ రివర్సిబుల్, వాట్ ఆర్ ఇర్రివర్సిబుల్ సైకిల్స్ అని. ఇప్పుడు చేతిలో ఉంటుంది, కింద పడేసిన దట్ ఈస్ ఇర్రివర్సిబుల్. ఎందుకు ఇర్రివర్సిబుల్? కింద పోయినప్పుడు ఐ డిడ్ నాట్ గెట్ ఎనీథింగ్, బట్ నేను ఓన్లీ బయటకు తీసినప్పుడు ఐ హావ్ టు డూ వర్క్. సో ఎనీథింగ్ దట్ హ్యాస్ డ్రాప్డ్, బ్రోకన్, anything you fail in the examination, that's irreversible. Okay, now if you tear a cloth or you break a chalk piece, you break a glass, anything is irreversible because you get what is irreversibility? What you can't get that back. Yes, you can get that back. If the glass is broken, you go and buy it, but you have to spend money for that. So, you got the glass back, but you became poorer by so much of money. So in this particular case, I dropped it, I am going because I am doing some work. So in the process, I have lost some work. This has regained its potential energy, but I have lost some work. So the concept of reversibility is that if you can restore the system and the surroundings in the same state as it was before, then we call it reversible. So all the examination examples చెప్పాను. గురువు పొద్దున పోయి సార్ దగ్గర సార్ నాకు అర్జెంట్గా బిల్లు ఒకటి కట్టాలి, 1000 రూపాయలు ఏంటంటే నా సార్ నాకు ఇస్తాను, 1000 రూపాయలు ఇస్తాను. నేను సాయంత్రం మళ్ళీ ఆ సార్ 1000 రూపాయలు ఇచ్చేస్తే neither he lost 1000 nor I lost. So that's a completely reversible transaction. ఎప్పుడు ఇర్రివర్సిబుల్ అవుతుంది? మీరు $1 తీసుకెళ్ళి బ్యాంకుకి ఇస్తే వాడు $85 90 రూపాయలు 85 రూపాయలు ఇస్తారు. కానీ నా తర్వాత మీరు చేంజ్ ఇవ్వండి, నాకు $80 వెనకాల కావాలి, $85 ఇస్తే $1 ఇవ్వడు బ్యాంకులో 90 cents ఎంత ఇస్తారు. సో దట్ ఈస్ ది ఇర్రివర్సిబుల్ ప్రాసెస్. మీరు రేపు సేట్ దగ్గర బట్టి కొట్టుకుంటాను, సేట్ దగ్గర పోయి డబ్బు తీసుకుంటే సేట్ every time you pay some interest, that interest is nothing but your irreversibility. So there are so many things in life which are, most of the things in the life are irreversible. Aging is irreversible, marriage is irreversible, or failure in the examination is irreversible because you got to go right once more examination. So this less than sign shows when it is irreversible, equal to shown signs when it is reversible. So if only a small quantity of delta Q is observed, now we have derived for a big system that actually constant Q1 is coming. But at the same time, let me say a situation something like this. I got so many heat sources, another check is heat and heat. So this engine gets heat from so many sources and it rejects so many sources. So each of them, let me say I am taking delta Q1, delta Q2. So each of them is going to get Q1, Q2, Q3. So what holds true for this system? Let me put this true. One holds true and the same. It also holds true even if they got any number of sources and things. So what we do is if it is taking only small quantity of Q from each of them, for example, we business organization. ఒక్కొక్క దగ్గర అయ్యా నాకు 10 రూపాయలు వాటి దగ్గర 20 రూపాయలు చేసుకున్నప్పుడు చాలా మంది వాటి దగ్గర చేతి బదులు తీసుకుంటామంటారు. చేతి బదులు తెలుసా హ్యాండ్లూమ్ అండ్ చేతి బదులు తీసుకుంటాము. సార్ నా డ్యూటీలు ఏమంటే 1000 రూపాయలు 1000 రూపాయలు కావాలంటే అది లేదు ఏం చేస్తారు, అయ్యా 20 రూపాయలు ఆయన 50 ఇస్తాడు, ఆయన 100 ఇస్తాడు, ఒక్కొక్క దగ్గర డబ్బులు తీసుకుంటాము. తీసుకున్న తర్వాత మళ్ళీ సాయంత్రం మనకి కూడా డబ్బులు ఇచ్చేస్తాం. అదే మీరు ఆ డబ్బులు లేకుంటే మీరు సేట్ దగ్గరికి వెళ్ళాలనుకోండి, వాటి 50 రూపాయలు ఇస్తే సాయంత్రం 55 అవుతుంది. So this is what I said. Then it becomes irreversible. So if you take small of them, so what it says is that the sigma, you have learned which you have plus sigma summation can be replaced by integral. Have you heard about this one? Summation can be replaced by integral. This is a calculus. Calculus is about calculus. 12th class. ఎట్లా పాస్ ఇంగ్లీష్ పాస్ చేసింది ఎట్లా పాస్ అయినా ఇంటిగ్రేషన్ ఫస్ట్ ఇయర్ మ్యాథమెటిక్స్ వచ్చాయి ఎట్లా ఈ సబ్జెక్ట్ క్యాల్కులేట్ చేసినావా చేసినప్పుడు summation is equal to చెప్పలేదా మీకు మన మాస్టర్ చెప్పాడా? So summation can be replaced with an integral. So again remember second law of thermodynamics holds good for whole cycle. So for the whole cycle, delta Q by T, summation of all the things, if you sum up all of them, that should be equal to less than or equal to 0. That's what it is. So this term delta Q by T being less than, that equation is called Clausius inequality. Inequality is less than or equal to Clausius. That's called Clausius inequality. So this is one of like example we have of the laws of thermodynamics. This is also one of the important things that we call Clausius inequality. Clausius inequality is cyclic integral delta Q is equal to less than or equal to 0. Okay. The sign holds would be equal to sign holds would when the cycle is reversible and less than holds would when the cycle is reversible. Now next question. To construct a cycle, should I have only all reversible process? Can I have one irreversible process? The cycle means only thing that complete the whole thing. So it doesn't mean a cycle doesn't put any restriction on you to use only reversible cycles. Of course, you cannot restrict with only irreversible cycles. One or two processes can be reversible as long as you come back to the same point. One or two processes. For example, if you go through a route where actually it is irreversible, for example, if you are going on a one-way traffic, it's irreversible. You can't go in the opposite direction, so it is irreversible. But then you have got to take a circuitous route, but still reach the same point. So the same thing, even in thermodynamics, we can have some irreversible process. One of the irreversible process examples is what it does is throttling. Like I said, dropping something, breaking there, are irreversible. In thermodynamics, throttling is actually an example of irreversible process. We will come to that later. So also note the second law holds good for a cycle, and it does not only put any restriction cycle being it doesn't put any restriction on whether all the processes are got to be reversible or reversible. I can have one. That later on we will see when you are doing the refrigeration, one of the processes in the refrigeration cycle is a irreversible throttling process. But still it is called a vapor compression refrigeration cycle, so we will be using that one later. Okay, now is it clear? A cycle need not have all reversible processes. It can have, but at least there has to be one reversible process, otherwise you can't complete a cycle, you can't come back and say this one. Okay, let's go back there. Now let us see. The cyclic integral also reminds the second law holds good for a cycle. You remember long back what did they say for the first law? The cyclic integral of work should be a plus cyclic integral of the heat should be equal to, so you remember this long back we derived the cyclic integral of Q plus cyclic integral of W should be equal to 0. Long back, much better. Acquisition should be taken to use. So we get it with that. Yeah, it's actually negative integral, negative of minus p dv. You remember that? We put the negative sign because that is the IU-back convention now. Yeah, so W is equal to negative of p dv because when you have positive much and dv has come to reduce. Your compression dv has got to reduce. So the compression one has got to be negative. So can we guess that the signal equal to W of p dv beta? Delta Q and delta W వాడంతా బంధువులు వాడు మీరు W కు మాత్రం మైనస్ p dv పెట్టి ఆ dq ఏదో చెప్పాలి కదా ఏదో ఉండాలి మైనస్ p dv. Can we guess that there is something which defines Q because Q and W they go together? But that's the whole idea of thermodynamics. So then similarly if there is something which says dq by d repeatedly keeps on coming back dq by t is something that comes out of second law of thermodynamics. And when we say that if I this delta Q equal to T times something. What is that something? Delta W is to minus P times something. That is here, that something was positive. So in the case of heat, then we have that something. W and P and P relations here on the right hand side where the P and P are properties. You know that this is P is extensive and intensive property. What is it? Extensive or intrinsic property? What's your mom? What's your phone? Huh? Extensive property. Difference in the extensive property. Pressure is the extensive property. Pressure mass divide just the extensive property, intrinsic property. Extensive properties are dependent on it. Intrinsic properties are dependent. Pressure depends on the mass level. But we are able to what is intrinsic property? What is independent? Independent is intensive. Huh? Don't get confused. So what is pressure? Extensive property. What about volume? What about volume? Extensive property. Okay, right. So, what is a product of one extensive property to one intensive property? You know, temperature only. Temperature extensive property and intensive property. Temperature extensive property. Extensive property. Intensive property. They are only the options. A, B, multiple choice questions. A, B, random tick just that you is the extensive or intensive property? Intensive property. Intensive property. Intensive property. Right. So this is intensive property. So this something that has got the extensive property. Obviously, common sense tells me that if work is a product of intensive and extensive properties, this has got the property of one intensive and extensive properties. That's all. So what we do is something that something is and here. The volume also depends upon the two states. Only one thing, but it is a constant, it depends on which way you go. But whereas pressure, volume, temperature, they are all state, they are all state, but it depends upon particular state. So similarly, this intensive property has got to be multiplied with something that has got to be a property of the system, whatever it is, the gas or whatever. Volume, the property of the gas, how much gas is contained. So this something that should remain intact during an adiabatic process. When it is adiabatic process, it will be equal to 0, which means that this something, the temperature cannot be equal to 0. So if adiabatic process is equal to equal to 0, then that something should become 0. The change is like here in the constant volume process, dV will be equal to 0. So constantly data is equal to 0. Correct? Constant volume process is what? Constant volume process to what is it? So చెప్పకపోతే అందరూ మీకోసం కాదు నేను చెప్తే ఆన్సర్ చెప్పకపోతే నేను ముందు చెప్పను నేను క్లాస్ తీసుకొస్తాను బట్ ఈజ్ యు నో ఇట్ సంథింగ్ ఆల్సో షుడ్ బి changing something that big there or something also should be good. Okay, that's what we do. We go to next. So what we do is that if it is a property, I have to show that it depends only on the states. Now let me construct a cycle which actually is state 1 and state 2. నేను ముందు ఎగ్జాంపుల్ చెప్పినట్టు ఇప్పుడు ల్యాప్టాప్ నుంచి ఇంజనీరింగ్ కాలేజ్ కావాలి కొందరు పాత్ర నుంచి చూసుకోవాలి సార్ కొంచెం సాయి దగ్గర చూసుకోవాలి సార్ ఓకే సో వన్ పాత్ ఇస్ యూ కెన్ గో బట్ ఏ 1 to 2 another you will go for 2. Can you remember the calculation? This is a cycle. The cyclic integral of the q by t should be less than or equal to 0. Let me say for the time being that process A and process B, both of them are reversible. If it is reversible, then cyclic integral of dq by t should be 0. Right. Now dq by t for cyclic integral, they are going from 1 to A, 1 along A and going to 2, 1 along A and going to 2, dq by t. Plus, then I am going from 2 along B to 1, 2 along B to 1, 2 along B to 1, dq by t equals 0. Okay? So now, if A and B are reversible, both of them are reversible parts. Cycles will be reversible. So the less than 0, if it is not reversible, if one of them is not reversible, it is less than 0. So now, okay, from here, that is the second law of my Cauchy's inequality we are writing for a cycle. Okay? Clear? Now, let us do the algebra. ఓకే ఆ డెల్టా గ్రేడ్ ఈక్వేషన్ రాసుకుందామా అది ఎక్కడ రాసుకుందాం రైట్ dq by t is equal to integral 1 into రాసుకుందామా ఓకే దాంట్లో ఒకటి calculate step you take one of the other side you can take either of them then I say t2 I have taken to the other side take the one to the other side ఇది రాయలేదు ఈ ఈక్వేషన్ రాసుకోలేదు నువ్వు ఇది ముఖ్యం అది అక్కడ మనం రాసుకోవా అక్కడ నుంచి ఇంకా ఆలోచన థర్మోడైనమిక్స్ లేదు ఆ తర్వాత దీనిలో దీన్ని మైనస్ ఇప్పటికే తీసుకోవాలి రాసుకున్నావా ఏమైంది ఇక్కడ మైనస్ సైన్ వస్తుందా మైనస్ సైన్ పెట్టుకోవా అక్కడ మైనస్ సైన్ మైనస్ సైన్ ఒకసారి మైనస్ సైన్ తినేస్తావు నువ్వు ఇక్కడ ఇది మైనస్ సైన్ ఉంది కదా ఇది మర్చిపోతావు ఈ మైనస్ సైన్ ఇది మైనస్ సైన్ కాపీ కొట్టడం కూడా తెలియదు అది ఓకే got it so minus sign అక్కడ ఉన్నప్పుడు then ఇంటెగ్రల్ లో మీకు తెలుసు if I change the lower and upper limits then it will become minus sign కదా so you do that one next so what it says is that when I am going from 1 to a2 along this path 1 to b2 along this path whichever way I go these values will be the same so that means whatever that equal to something is independent of the path that is taken, it is independent of these two states. So it becomes that something is only property of the state like pressure, temperature, volume, and all those things. This is what is called a state function. Whatever goes along with depends upon the path, we call it as a path function. So if your level of thermodynamics would you work and keep our path functions, all the other pressure, volume, internal energy, temperature, they are all state functions. In other words, what we do is that the integral remains the same order path. So we simply ignore the part that property is called entropy. E-N-T-R-O-P-Y. That's why I want to give this concept of entropy. So now if you remember your steam tables remember pressure, temperature, specific volume, then you have internal energy, then you have enthalpy, then you have cost, you have two curves. I told you I will tell you later. Let's take the black boxes later. So you don't know what the STM tables is. What's sauce it is? What's up? STM tables open to you. Cell phone ఉందా లేదా తీసుకోవాలి నీ దగ్గర ఉందా సెల్ ఫోను అక్కడ ఉందా ఎవరి దగ్గర ఉందా సెల్ ఫోన్ ఇక్కడ కెన్ సమ్మన్ కమ్ హియర్ నీ సెల్ ఫోన్ ఉంది కదా స్టీమ్ టేబుల్స్ పంపించారు కదా ఆయన వాట్సాప్లో ఓపెన్ చేయి వాళ్ళకి చూపించాలి ఆయన కళ్ళు సరిగ్గా కూడా బాగుంటుంది వేరే ఓపెన్ చేసుకొని ఎక్స్ప్లెయిన్ చేయాలి దొరికిందమ్మా ఏదైనా ఒక ఫస్ట్ పేజ్ తీసుకుంటాను యూ డోంట్ నీడ్ ఆల్ థింగ్స్ ఓకే ఫస్ట్ పేజ్ తీసి రైట్ ఎక్స్టెండ్ కాలం నాకు రైట్ ఎక్స్టెండ్ మాట దొరికిందమ్మా ఏముంది అక్కడ SFG nothing but SG minus SF. Actually, you don't need it, but still they have given because they know that some of the students are lazy. You don't have patience to take one out of subtract, and well, the SFG kuda valle ichcharu. So that is what is the value of entropy. That's why you need entropy, also a part of the steam table, which is actually property of a fluid that you are talking about. Okay. Now, what are the units of entropy? So the units of entropy QM units. What are the units of Q? Heat and the units. Joules per kg. Okay, all right. But the Q is the joules. Temperature units. Huh? Celsius are degree Kelvin. Up to dQ by T and then the unit Q Q joules or joules per kg, temperature Kelvin, no? Joules per kg, whatever entropy unit name it. Joules per kg, joules per kg Kelvin, no? Okay? What is unit of entropy now? If it is capital S, unit is mass is not there. If it is capital S, unit is there. This is the unit of joules per Kelvin. The lower case S, it is joules per kg Kelvin. Right, remember? We had the capital V for volume, specific volume is meter cube per kg. We said internal energy, so many kilojoules, or if it is lower case U, it is kilojoules per kg. Enthalpy, if it is capital H, it is so many kilojoules, if it is per unit mass, specific enthalpy is kilojoules per kg. What is listed in your state tables is everything is a specific volume, specific internal energy, that's like in lower case U, specific enthalpy, and also specific entropy. So that's a lower case S, that is what is marked in your stream tables. No, you don't know how to use the stream tables. So capital S has got unit of joules per Kelvin, and lower case S they have a unit of joules per kilogram Kelvin. Can you tell me, is there any other property which has got the same unit? Joules per kg. Then what is it? What is it? Need something like what is it? Moles per molar specific heat. If it is mass per kg, molar specific heat kavalante is the outcome. Chemical engineers, man, moles are like a kg lo chekkanna. Mechanical engineers kg lo. What will be the unit of specific heat or entropy? It is moles. నువ్వు చెప్పకపోతే అట్లీస్ట్ రాసేదే చూపించుకోవడం ఎంత వాట్ ఆర్ ది యూనిట్స్ ఇఫ్ ఇట్ ఇస్ మోల్స్ జూల్స్ పర్ కేజీ కలిపి నువ్వే చెప్పినావు కదా కేజీ అయితే మోల్స్ అయితే వాట్ విల్ బి ది యూనిట్ మోల్స్ కెమికల్ ఇంజనీర్స్ మోల్స్లో లెక్క పెట్టేది మనం కేజీలో చేయం మనం వాట్ ది యూనిట్ ఆఫ్ స్పెసిఫిక్ హీట్ ఇన్ మోల్స్ ఎంత moles specific heat in moles. If it is kg, joules per kg. If it is moles per kg, but entropy doesn't change. It is going from 2, 3, isothermal compression, its temperature, the horizontal line shows that temperature is constant. Then 3, 4, adiabatic process, it is a compression. When you go from 3 to 4, this temperature is higher than this temperature. Then you get the 4 temperature cool money. Nowadays, this is adiabatic process. 3 to 4, then 4 to 1. So, the carbon sample which is having a funny shape and pressure over the background looks like a beautiful rectangle on the TS diagram. Right, what we have, right, we have this one. So, we said that whatever is here, the area under that one, you see what is it? Area under the PV diagram. ఏరియా అంటే పివి డయాగ్రామ్ ఏది ఇస్తుంది క్యాన్వస్ సింగిల్లో బుక్లో లేదా నీకే తెలియదు బుక్లో రాసుకోలేదు నువ్వు అప్పుడు క్లాస్కి రాలేదు నువ్వు వాట్ విల్ ఏరియా అంటే పివి డయాగ్రామ్ ఏది ఇస్తుంది తెలియదంటే తెలియదు ఎవరికి తెలుసు ఏరియా అంటే డయాగ్రామ్ ఏది ఇస్తుంది వాట్ విల్ ఆయన దగ్గర రాదే రాదు ఆయనకు చెవిలో చెప్పు ఏరియా చాలా తెలియదు చెవిలో చెప్పాడు ఇక్కడ దగ్గర పోయి చెవిలో చెవి చూపించాను నిలబడు ఆయన పోతే నిలబడు ఆయన చెప్పేస్తాను చెవిలో చెప్పు బట్ దిస్ ఇస్ వన్ ఫ్రమ్ నౌ ఆన్ as anyone who doesn't answer I'm going to ask other people to go teach them. Okay, area అంటే this one will be there. But ఇంకోటి ఫస్ట్ ఆఫ్ పర్మనెన్స్ ఏంటి చూద్దాం. ఫస్ట్ ఆఫ్ పర్మనెన్స్ ఏంటి cyclic integral of full cyclic integral of heat and cyclic integral of work should be equal to 0 కదా ఇక్కడ చూద్దాం దీనిలో cyclic integral మనకు మైనస్ w వస్తుంది కదా ఓకే సో cyclic integral of this one will give you minus W, that's what you have done. W is W. Upon A is the, what will that one be? Exactly equal. You know that this one on the PV diagram, the first class terminal that is so that means segregated to Q should be equal to negative of segregated to W, right? And just repeating the first of the model is the segregated diagram of W. దీనికి వచ్చింది అప్పుడు ఇదే ఒకటి ఈ ఏరియా ఏముంటుంది వాట్ ఇస్ దట్ ఎంత అవుతుందమ్మా ఆ రెండు సమానమేనా అది సైకిల్ దీనిలో సైకిల్ గిట్టే డబ్బులు ఎప్పుడు చూపించుకున్నాను ఎక్కించుకున్నాను అప్పుడు అదేమైతుంది అది సైకిల్ అది డీక్యూ అవుతుంది కదా సైక్లింగ్ డబ్ల్యూ ఈక్వల్ సైక్లింగ్ అప్పుడు అదేమో ఆ ఏరియా ఆ టీఎస్ డయాగ్రామ్లో ఈ ఏరియా ఏమవుతుంది వాట్ విల్ బి దట్ పీపుల్ అప్పుడు అది ఫస్ట్ అర్థం పడండి ఎంత అవుతాను ఆ రెండు సమానమా కాదా this will be exactly equal to that because on the PS diagram the one the area what you get is dq by dq is equal to dps area integrate chese what like you have what coming on a PV diagram heat actually is come on the PS diagram. So numerically because the area under this one should be exactly equal to the area that's what is the first outcome. Okay, so area అనేది ఇప్పుడు చాలా ఈజీ అంటే ఇక్కడ ఈజీగా కట్టాలంటే వాటి మీద వర్క్ బట్ ఏరియా రెక్టాంగిల్ ఎంత చెప్పండి ఎంత ఇక్కడ దిస్ ఇస్ S1 is equal to S2 and S4 is equal to S3. What is the area? Come on guys, let me say that this is S1 and this is S4. Area of rectangle ఎంత ఇది width and height ఉంటే ఎంత rectangle area, that's what I am asking for. Right, please write it down. What is the area? Area under the area under this diagram. What is the difference between the two? What is this area is nothing but this times this. Here it is S1, here it is S4. What is the width of that? S1 minus ఈ హైట్ ఎంత ఇక్కడ T1 ఇక్కడ T2 హైట్ ఎంత సో ఏరియా ఎంత అప్పుడు ఎంత హౌ మచ్ ఇస్ ఏరియా నౌ you last second ఈ హైట్ ఇక్కడ T1 minus T2 కదా ఈ బిట్ కదా S1 minus S4 ఏరియా ఎంత Right, there is a lot of it. I'm not asking for any miracles. It is just simple, it is not even high school, elementary school mathematics. Which is the Mariko? And the area? T1 minus T, S1 minus S4 into T1 minus T2. So that is the area. So this one should be equal to that. What is that area? On PV diagram, what is the work done in a Carnot cycle? మన అందరినీ బయటికి పంపించి లెక్క పెట్టారు ఇంకా మీరు చేయలేదంటే మీరు చేయలేదు రాదు బయటికి పంపించారు చెప్పండి దాని లెక్క పెట్టడం ఎంత వాట్ ఈస్ వర్క్ అనుకుంటుంది ఈ డైరెక్ట్ క్యాబ్నో సైకిల్లో ఎంత వర్క్ ఎంతమ్మా నో T1 minus T2 అది ఎఫిషియన్సీ but here, so this area T1 minus T2 S1 minus S4, that's a have work done, I'm not asking for it. Minus will be also equal to S2 minus S3 or minus of S3 minus S2. Okay, this so integral under this one gives the work, so work integral under this one gives the work. Heat. Here there is no problem always this is a positive quantity because again you see one thing. Here this whole cycle because it is going in a clockwise direction. It gives out work. Receives the heat and gives out work. Similarly, here also if it is going in a clockwise direction, because PV and PS diagram they are just analogous to each other. When it goes in a clockwise direction, it will still give out work and will still receive heat. When it receives heat, why it is receiving heat? You remember in this process, when it went from 1 to 2, this was equal to 1 to 2 was 0, when it was 4 to 1. What's happening here? It is pending. It was receiving heat. Remember that? ఇక్కడ Q లోపలికి వస్తుంది. ఇక్కడ Q బయట కంప్రెషన్ Q బయట పోతుంది. ఇక్కడ Q లోపలికి వస్తుంది కాబట్టి when it went from 4 to 1, it is actually receiving heat. The heat received here is nothing but T1 minus T4 times S1 minus S4. That is the heat that is received. ఇక్కడ and this one 2 to 3 when you are going to isothermal compression, when you are going from 3 to 3. The heat that is given out is nothing but area under this. So the area which is area is the this. So again same rest of thermodynamics. Numerically Q1 minus Q2 will be equal to minus W. Here actually sum of Q1 like because here the direction is different. Here the direction is different. Here the opposite direction. So we have this Q1 plus Q2 plus 0. Full cycle. The same thing for smoking. So Q1 is nothing but T1 which is same as T4 multiplied by S1 minus S4. Q2 is nothing but, of course it will be negative, S3 minus S2 multiplied by T2. That will be heat rejected. So heat supplied minus heat rejected will be essentially the area of the cell. That's what exactly we have to do. First, then I mentioned earlier, Q2 will be negative, you have to remember, because it is going in the other, because S3 will be lower than S2. So, TS diagram, PV diagram, they become first cousins. Whatever happens there, it also happens there. Two areas will be equal, and it is not easier very times to represent. Here, because it has a complicated shape, now you see that it's so beautiful, just a rectangle, so easy to calculate areas. So sometimes in engineering fellows and girls, we use TS diagram if it is convenient or PV diagram. So the plane on which you want to make a calculation, it is your choice, whatever is convenient for you. Sometimes it is easy to do on this one, sometimes it is easy to do. Now what we are going to do a little bit from the next class, that is I am going to do what is called the Carnot cycle factorization. There is another Carnot cycle, as you know, there is no way you can build a Carnot cycle. Practically, the engineering work, you come to change. It's only an ideal cycle, which I told you earlier. But we require power, we require energy, we require raise in potential energy, short power recovery. So we have to build practical cycles of various amount. So we try to modify this Carnot cycle, see how close we can get to it. One of those cycles with which actually we produce all the power everywhere is what is called the Rankine cycle. Rankine cycle is steam, the biggest steam tables in each other. That's also the reason why I told you what entropy is. And that entropy will be using that for the calculation for steam cycle. Refresh whatever I told earlier. Next class, all of you, I want everyone to bring all the notes. And all those classes are the equal notes, the shifting utilization, చెప్పొద్దండి లేకపోతే పొట్లా పెట్టేదానికి బయట బచ్చిలో మేము పొట్లా పెట్టేదానికి నేను ఆ నోట్స్ ఇచ్చేది చెప్పండి. Maybe you will do it one day when the class is over, the course is over. Upon you want to put up at the notes. I want everyone to bring every notes because when I ask you to open and show me, I will show you. Okay? Right, so we'll stop there for today. Next I will introduce what is called entropy and what is its role in irreversibility. Irreversibility and చెప్పాను, some processes take place on the boss. So what is the role of entropy? Entropy is something which actually decides whether something is being done reversibly or irreversibly. So when I example చెప్పినప్పుడు సార్ దగ్గర నేను అప్పు తీసుకుని మళ్ళీ తిరిగి చేస్తే irreversibility is equal to 0. అదే నేను సేట్ దగ్గర తీసుకున్న డబ్బులు చేస్తే reversibility is irreversible. So what defines the in thermodynamics, what is the difference between reversible and irreversible? అది Sloman person. No, Friday. Friday. Thursday. Friday. Thursday. Tomorrow morning I think Palma seconds. I will do it on Friday. Okay. Reversibility. Please brush up and whoever doesn't know, Ali come this goes Ali also come up. Okay. Thank you. Any questions? Any questions? సార్ చెప్పినట్టు ఎన్నిసార్లు అది పొద్దు నుంచి సాయంత్రం వరకు ఒక్కరు కూడా నా దగ్గర క్వశ్చన్ అంటే అడిగారు వాళ్ళు వచ్చి మీకు డౌట్స్ లేవా? డౌట్స్ లేవని చెప్పేది లేదు, ఎందుకంటే ఒక్కరికి సగం పై నేను అర్థం కాలేదు. ఏ క్వశ్చన్ అయితే మీకు చెప్పదు. బయట కమని లాస్ట్ క్వశ్చన్ యూఆర్ లేట్ వాట్ యూ కెన్ డూ. ఇఫ్ యూ డోంట్ వాంట్ టు హెల్ప్, ఐ మీన్ ఐ డోంట్ వాంట్ టు రైట్ ఐ ఫీలింగ్ హార్స్. ఇట్స్ అప్ టు యూ పీపుల్ టు యూస్ అవర్